Hello everybody and welcome to the Kreatryx YouTube channel. I welcome you all in a fresh session of analog electronics. And my dear friends, when I say we are going to learn analog electronics from the very basic, I mean it. We will be learning from the very basic level to the very advanced level along with a lots and lots of questions. So before we do that, let me first introduce myself for my friend who is meeting me for the first time. My dear friends, my name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have trained more than 1 lakh students in the online and the offline classes and presently working as a director at Unacademy for GATE department. But my dear friends, the reason behind this series is because of the huge demand of analog electronics and the belief that whenever you ask for anything, we are there to deliver. Yes, my dear friends, we are here for you. We are here delivering for you. And when we say it, we will support you to the very fullest level. And this series will help you crack GATE with the top rank. It will enable ECE student to get 12 out of 12 and 5 out of 5 for electrical students. So my dear friends, if you want to learn with us live, then you can join Unacademy using the code Ankit ESE to get an immediate 10% discount. And not only, my dear friend, 10% discount, it also brings you under my guidance so that I can help you do something that I have done. I can at least take you near to this goal. Okay. So if you also dream the same thing, then join me in this journey on Unacademy subscription using the code Ankit ESE. Now, my dear friend, if you like the content that I deliver, you can watch more of my free videos on this URL, tinyurl.com/AnkitESE. Here you will find all my videos arranged subject-wise, chapter-wise, and you will find great content for free. And you are definitely going to love it. You are definitely going to enjoy. It not only includes conceptual videos, but it also includes problem-solving sessions. So just visit this once and you will fall in love with this URL. Don't forget it. It is a lifeline for you. And if you love the content that we are delivering on YouTube, we have created the first ever video book for you guys, where you will find all the videos along with all the notes that we provide arranged subject wise, chapter wise. So now, my dear friends, your dreams are no longer dreams. They are becoming a reality because you are getting a top quality course, well arranged, well structured, and that too for free. So what can be better than that? What can be better than that? Nothing, my dear friends. So we have empowered the dreams of those who earlier used to think that only the person with a huge amount of money can crack GATE with a top rank. No, my dear friends, that is not the case. Even you can do. Even you can do it. But yes, just you need to believe in yourself and visit this link. But remember, this is a case sensitive link, so write this in uppercase. Other than that, if you join plus subscription, you get all the top educators like me teaching you live in daily lectures, along with providing you daily practice paper, weekly quiz, test series, previous year question, practice question, crash course, rank improvement batch, and most importantly, clearing your each and every doubt. So if you join plus subscription, it is an entire world inside it. So you don't have to look outside. Once you enter plus, every need of yours will be taken care of, and we will make your journey as smooth as possible towards that destination of getting under 100, under 10 rank. Believe me, my friend, you leave that strategy part to us. You leave the content part to us. You just work hard and we will make sure that you obtain the top rank in GATE and ESE. And Iconic is a big brother of Plus. Yes, this is a little brother. So Iconic gives you everything that a Plus subscription gives, along with much more. The major part of Iconic is this personal coach, a person dedicated to you on a daily basis to get you the top rank, guiding you, getting your schedule design, making your strategy. Everything that you need to get the top rank is being done by this personal coach. He'll also create a study planner for you, which you can follow blindly and reach your destination with utmost ease. They will be analyzing your test result and tell you where you are lacking, how you can improve. So that way, my dear friend, everybody else will get a standard analysis, but you will get an analysis just tailor-made for you. Along with it, we have included study material additionally, theory and question bank, and soon we'll be introducing interview guidance into this. So this will become a complete package for a student who wants to take that journey from being an average student to sitting into a PSU or a MTech seat. So for them, this journey will be just like driving a Lamborghini to work. So that sort of a experience, that sort of a royal experience we are going to give you. So let's move on to the lecture, and if you want to join Unacademy, just make sure you use the code Ankit ESE to get my guidance as well as to get 10% over and above whatever Unacademy offers you. So now let's move on to the lecture, dear friends, and let's see what we have in store for you.
Hi guys, in the last video I introduced to you the concept of feedback amplifier. So I told you what is a feedback amplifier. It is a closed loop amplifier configuration in which a fraction of output signal is fed to the input terminals. Okay, so I showed you the basic block diagram of a feedback amplifier, and in the block diagram we saw that there are basically two components that are very important. One was the mixer network that was used at the input terminal, and the other one was sampling network, okay, that was connected at the output terminal. And then we saw that even in the mixer network we can mix either voltage or current. Similarly, in the sampling network, you can either sample the output voltage V0 or you can sample the output current I0. That is what we saw in the last video. And then we saw that the gain after feedback was A over 1 minus A beta for positive feedback, and it was A over 1 plus A beta for the case of negative feedback. Okay, that we saw. Then I told you about sensitivity, which is the ratio of percentage change in the closed loop gain with respect to percentage change in the open loop gain. It was 1 over 1 plus A beta square. So in negative feedback, the sensitivity reduces, and due to reduction in sensitivity, the closed loop gain does not vary much with respect to the change in open loop gain. And the desensitivity was equal to 1 by sensitivity. Then I told you, due to negative feedback, distortion and noise both decrease, whereas the bandwidth of the system increases. Okay, so this we saw in the last lecture, and I also told you, based on configuration of mixer and the sampling network, we can have 4 possible combination. Okay, so we can talk about 4 possible combination based on which quantity is being sampled and which is being mixed. So what are the 4 combination? The first one is called as series shunt feedback. Series is representing here the mixing network and shunt sampling. If you are mixing in series, it means you are talking about the voltage. If you are sampling in parallel, it means you are talking about V0. Okay, that means at the output also you are taking voltage, and at the input also you are taking voltage. You can also write it like this: voltage series feedback. But when you write it like this, the first term will always represent sampling, that we are sampling the voltage, and the second term will represent mixing. So if you write like this, series shunt, the first term is mixing, second one is sampling. If you like voltage series, then the first term is sampling and the second one is mixing. Similarly, let me ask the second one. Suppose I write shunt series feedback. Then shunt means it is representing mixing. Mixing in parallel, so it is current. Series means sampling in series, it is current. So what you will write? Current is being sampled and it is mixed in shunt. So current shunt feedback. Okay. So these are the two possible cases. Let me represent other two also. Okay. So suppose the third one I ask is series. The first series represents mixing. The second series sampling. So what you will say? Sampling is current and then mixing is series. So current series feedback. Okay. And the last one, shunt feedback. So shunt is mixing. Mixing is shunt means current. Sampling is shunt means voltage. So it will be what it will be called as? It will be called as voltage shunt feedback. In the second naming, always remember that this represents sampling and this represents mixing. So that is how we have 4 configurations for the feedback amplifier based on the quantity being sampled and the quantity being mixed. So from this lecture onwards, we will be studying about these 4 configurations. So in this lecture and the next one, I will explain you the all 4 configuration. So let me start with the first one. The first one is the series shunt feedback. So let me again write down. Series means this is mixing. Mixing in series means voltage. Shunt is sampling. In parallel, which quantity do we measure? Voltage. So feedback is voltage and output is also voltage. If input and output both are voltage, it is voltage amplifier. The voltage amplifier is also called as voltage controlled voltage source. So now see, there are 4 names for the same thing: voltage amplifier, voltage controlled voltage source, series shunt feedback, or voltage series feedback. You can write this using 4 names. See, in the forward path we have a voltage amplifier having a gain AV. So in the forward path we have a voltage amplifier. In feedback path we have a voltage gain of beta, and the feedback voltage is connected in series with the supply voltage, and the sampling is in parallel to the load resistance. Okay, because sampling is shunt whereas the mixing is series. So at the input side we are connecting in series, but at the output side we are connecting in parallel. Now basically the voltage amplifier has a very simple circuit. If I talk about the circuit of forward path, this is the input resistance. Across this resistance I take input voltage Vi. Then we have a dependent voltage source in a voltage amplifier AV into Vi in series with the output resistance R0. Okay. So that is simply the voltage amplifier that I have shown in the forward path. Now this feedback voltage Vf, since feedback factor is beta, it is beta V0. Because see, the input to the feedback path is V0 and the output of the feedback path is Vf. So Vf is beta V0. This beta is called as feedback factor. Now what you have to do in order to draw the complete circuit, you will show like this: Vs in series with a dependent voltage source which is Vf. What does it depend on? Vf depends on V0. Then I'll replace the voltage amplifier by input resistance Ri and a dependent voltage source AV Vi. What is Vi? Vi is the voltage across resistance Ri, and then it is the load resistance RL across which we take the voltage as V0. So I'll show the voltage here as Vi. So if you apply KVL, what you can tell about Vi? You will say Vs minus Vi plus, sorry, minus plus I have marked opposite. It is like this. Okay. From here I am taking the polarity. Minus beta V0. So Vi will become Vs minus beta V0. And if you apply voltage division in this loop, you can say that V0 is the voltage source is AVVI into the factor of voltage division RL by R0 plus RL. So AV Vs minus beta V0 RL over R0 plus RL. So you can say V0 is AVVs RL over R0 plus RL. Okay. Minus what it will be? AV beta RL over R0 plus RL into V0. Take the terms containing V0 on the left hand side. This will be the relation. Now what I'll do is I'll consider this term as AVL. This I explained to you in BJT. When we consider the effect of load resistance, then the effective voltage gain is written as AVL. So V0 is AVL. This term multiplied by this is also AVL. 1 plus AVL into beta into Vs. So what is the gain? Gain is AVL over 1 plus AVL beta. The same relation we derived using the closed loop system, that is the voltage gain. Okay. Even if you want, you can also consider the source resistance Rs. Okay. If you consider the source resistance Rs, then there will be another term of voltage division between Rs and Ri. So what I mean to say here is, suppose you consider a source resistance here. Suppose this is the source resistance. Then Vi will have another term, which will be Ri over Rs plus Ri. This voltage will be divided into two resistances, because earlier the entire voltage was appearing across Ri, but now it will be divided between Rs and Ri. So what we will have is, we will have another term Ri over Rs plus Ri. Ri over Rs plus Ri. And combining these three factors, AV, RL and Ri, these three terms can be called as AVS. Okay, that is the overall voltage gain. Remember, in BJT amplifier I told you about the three voltage gain, AV, AVL and AVS. So the same thing I am telling here, you can represent the overall voltage gain by AVS. Okay. Now the other thing that I need to find out is the input resistance. The effective input resistance we want to find out. Okay. So suppose this is the circuit containing Rs also, This current is the input current. So if I apply KVL in this loop, what you will write? Vs equal to IIRS plus IIRI plus beta V naught. Okay. Now how you can write V naught? V naught is AVS over 1 plus AVS beta Vs. Okay. Take the terms containing Vs on the left hand side. 1 minus AVS into beta over 1 plus AVS beta. IIRS IIRI. That means Vs. If you take the LCM is 1 plus AVS beta. So it will become 1 over 1 plus AVS beta IIRS plus IIRI. So Vs will be IIRS into 1 plus AVS beta plus IIRI into 1 plus AVS beta. So effectively the input resistance does not consider source resistance. I have always told you, when finding the input resistance, always ignore Rs. So this term on the right hand side will be called as RIF, that is input resistance with feedback. Okay, that is input resistance multiplied by 1 plus AVS into beta. So that is the overall gain. Okay, sorry, the overall input resistance. Is it fine? Next term that I need to find out is the output resistance. Okay. So if you want to find out the output resistance, then what you need to do is see this. Okay. This current is I naught. First of all, when we are finding the output resistance, we do not consider the load resistance RL. Always remember, you will not consider the load resistance RL. So if you apply KVL in the loop on the right hand side, what you will say? AV VI is equal to I naught R naught plus V naught. Okay. But we don't consider RL. AVVI equal to I naught R naught V naught. How you will write V naught? First of all, let me write down VI. 1 minute. How will I write VI? VI is simple. Vs minus beta V naught into a factor of voltage division. How I have written this? See. In the input loop, what is the total voltage? The total voltage is Vs minus beta V naught. Okay. And this voltage is being divided in two resistances, Ri and Rs. So what is the voltage across Ri? The total voltage into a factor of voltage division. And what about V naught? Or leave it like this only. Just write here AVVS minus AV beta V naught Ri over Ri plus Rs equal to I naught R naught plus V naught. Okay. So now what you will do now is AV Vs. Okay. 1 minute. Sorry, there will also be a factor of Ri over Ri plus Rs here. So what I'll do is I'll combine these two terms, or let me call as AVS. Okay, this term minus AVS beta V naught I naught R naught plus V naught. Collect the V naught terms on one side. Now if you make it just V naught, you will have to divide it by 1 plus AVS beta. So the term with I naught is called as output resistance with feedback. It is divided by a factor of 1 plus AVS beta. So what you can say? R naught F is less than R naught. Okay. Now, what is the best way to remember this? The gain becomes AVS over 1 plus AVS beta. So the gain reduces. Bandwidth. Bandwidth becomes original bandwidth multiplied by 1 plus AVS beta. So bandwidth increases. Then the third thing, it is a voltage amplifier, right? Series shunt feedback represents voltage amplifier. If you refer to the earlier lecture about the 4 type of amplifier that I have taught you, I have told the input resistance must be high and output resistance must be low. In order to increase the input resistance, multiply it by a factor of 1 plus AVS beta, and in order to reduce the output resistance, divide it by a factor of 1 plus AVS beta. So input resistance will increase and output resistance will decrease. That means by the use of feedback, we are able to satisfy the requirements that we had set earlier for the amplifier. We are able to satisfy the requirement of the input and the output resistance. Okay. Moving on to the next one, the next feedback is called as shunt feedback. So the first shunt represents mixing. Mixing in parallel means current. The second shunt, sampling. Sampling in parallel means V naught. Okay. So that means here the feedback quantity is current and the sampled quantity is voltage. So when we talk about the feedback factor, it will be IF by V naught is beta. What will be the unit? The unit will be mho or Siemens. Current upon voltage is mho. Now since the input we have current and the output we have voltage, what kind of amplifier is it? It is trans resistance amplifier. Okay. So trans resistance amplifier means it is converting current to voltage. So the input side we have current and the output side we have voltage. Okay. Now see the basic structure. We have the source current and in parallel we are having the feedback current IF. The remaining current will be input to the trans resistance amplifier written as II. But sampling is done in parallel with the output terminal. So sampling is V naught. Now what is the circuit of this trans resistance amplifier? If I just draw the circuit of this amplifier, we have input resistance on the left hand side, but we are taking the current of this resistance. Then we have a current controlled voltage source RMII in series with the output resistance. So basically it is a trans resistance amplifier. What is it also called as? It is also called as current controlled voltage source. Okay. Trans resistance amplifier is also called as current controlled voltage source. Okay. So now our objective in this amplifier also is to identify the gain, the input resistance and the output resistance. So let us draw the model. First I will draw the supply current IS. Now if we have source resistance as well, it will have a resistance RS in parallel to IS. Then there will be a dependent current source going downwards, which is IF, which is equal to beta V naught. And then I'll replace trans resistance amplifier by its equivalent circuit. So I'll show RI, and the current in RI is II. Then we will have a dependent voltage source RM into II in series with output resistance R0, and then the load resistance RL. The voltage across load resistance will be V0. Okay. So now the first objective is to find the voltage gain. So in the right hand side, if you apply voltage division, you will say V0 is RM II into RL over R0 plus RL. Now how to find this II? Basically there are two current sources in parallel, IS and IF, and they both are in opposite directions. So the net current is IS minus IF. And if you want to find II, there are two resistances in parallel, RS and RI. So you will have to apply current division. I net into RS by RS plus RI. Okay. So what is II? IF is how much? Beta V naught into RS over RS plus RI. Okay. So now when you substitute it in the expression for V naught, it is RM into RL over R0 plus RL into RS over RI plus RS into IS minus beta V naught. If you club these three terms, I will write it as RMS IS minus beta V naught. Now collect the terms containing V naught on left hand side. 1 plus RMS beta, RMS into IS. So V naught by IS, that is the gain. It is RMS over 1 plus RMS beta. So RMS is the overall gain in absence of any feedback. If the beta was 0, then the gain would have been RMS, but due to presence of feedback, the gain is reduced by a factor of 1 plus RMS beta. Okay. So that is the expectation from negative feedback, that the gain must reduce. Now the next objective is to find the input resistance. How do you find input resistance? Basically, what I'll do is, I will write this voltage as Vi. So if I apply nodal, what I'll say? Is is the incoming current, beta V naught is outgoing. So Vi by Rs plus Vi by Ri. These two are also outgoing current. Okay. This current and this current is outgoing current. Now how you will write V naught? V naught will be RML into IS. Okay. So how I am writing RML? I am using RML because when we are finding the input resistance, we don't consider RS. don't consider RS in gain while finding input resistance. Is my point clear? This I have told you multiple times, that when you are finding the input resistance, we don't consider the source resistance, and that is why the gain instead of RMS is becoming RML. So this is IS over 1 plus RML beta VI over RS plus VI over RI. Now this will be IS VI RS over 1 plus RML beta plus VI RI over 1 plus RML beta. So the input resistance with feedback becomes Ri over 1 plus RML beta. So what you can say? The input resistance is less than its open loop value. Earlier the input resistance was higher, but now it has reduced. Why it has reduced? Because you are connecting it in shunt. Whenever we are connecting in shunt, the resistance must reduce. The last term that we need to find is your output resistance. Okay. So we wish to find the output resistance. How will you find it? We will consider a current I naught here. So if I apply KVL, I'll say RMII is I naught R naught plus V naught. Don't consider RL when you are finding the output resistance. Now how do you write II? II was obtained by applying current division in the net value of current. This was the net current. See, I wrote here, this is the net current, and we applied current division. So RS over RI plus RS. So it is RM RS over Ri plus RS into IS minus RM RS Ri plus RS beta V naught I naught R naught plus V naught. Now this term RM RS over Ri plus RS I will write as RMS RMS beta V naught I naught R naught plus V naught. Collect the term containing V naught on one side. Okay. Now divide it by the coefficient of V naught. What you will get? Okay. So this term in product with I naught is called as output resistance with feedback. It is R naught over 1 plus RMS beta. So it is less than R naught. Again, because output is in shunt, the output resistance has reduced. So now what you have to remember? Due to negative feedback, the gain will reduce. It will be RMS over 1 plus RMS beta. Since both are in shunt, input and output both resistances will reduce. But while taking input resistance, we will take RML, and while taking output resistance, we will take RMS. Because while calculating input resistance, we ignore source resistance, and while calculating output resistance, we ignore load resistance. So if I summarize what we have covered in this video, I have told you first of all about series shunt feedback. which is also called as what? Voltage series feedback. It is voltage amplifier. So gain reduces, input resistance increases, output resistance decreases. The second one was shunt feedback or voltage shunt feedback. This was your trans resistance amplifier. Okay, here the gain reduces, input resistance decreases, as well as output resistance decreases. Okay, so we have covered 2 configurations out of 4 in this video. In the next lecture, I'll tell you about the 2 more configuration, and then we'll talk about how to identify which configuration is being used in a particular network. Okay, that we'll cover in the next video. Thank you.
I hope all of you have enjoyed the lecture that we were providing and all of you learned something very good. Now is the time to learn about the Unacademy subscription. So as I told the benefits of the Plus subscription at the very beginning, let's go through them very quickly. Live classes you get by the top educators, crash course, rank improvement batch, doubt clearing, weekly quiz, test series, previous year question, practice question, everything in one subscription called as Unacademy Plus. And iconic is one level higher. It provides you a personal coach who will mentor you on a daily basis, who will guide you on a daily basis, along with providing you study planner, test analysis, study material, and soon enough interview guidance. So if you are looking to join Unacademy, let's see what are the pricing. So my dear friends, before we see the pricing, just see the link. This link will help you crack GATE and ESE with the top rank, because we have created the first ever video book for GATE and ESE for my YouTube family, and you will get the notes as well as the lectures here. Just make sure that you write this link in the uppercase and you will get to the first ever video book for GATE and ESE, and it is nothing but revolutionary. Now let's see the pricing of Plus subscription. So for 12 months the pricing is 3250, but if you apply the code Ankit ESE, it becomes 27225. For 18 months it will be 34650, and for 24 months 39600. Believe me my dear friend, this is the most affordable pricing, and the longer duration subscriptions are more cost effective as compared to shorter duration. Like here it will cost you 1650 per month. Okay, this will be 2000 per month approx. This will be around 2250 per month. Then if you go for iconic for 12 months, it is 5250. With code Ankit ESE it becomes 45225, and 2-year subscription becomes 66600. So the choice is yours, but take a longer duration subscription for more cost effective solution, and to give GATE and ESE at least 2 times, so that if you once crack GATE, in the next attempt you can even get ESE. And other than that my friends, you can download the Unacademy learning app right now, because there we provide live classes for free, test series and live quizzes for free. And once you download it, make sure that you follow this profile. This is my profile, so that whenever I come live you will get the notification. And this is the Telegram channel for our team. Here you will find all the lecture links, all the lecture files, and all the links for the special classes. Other than that my friend, my personal Telegram channel also you can join, t.me/GateAIR1. Here you can get in touch with me and we can take this journey together. Okay. Other than that, we have other YouTube channels like Mechanical, Civil and Telugu, JE channel, Computer Science, Gate Question and Electrical Junction, Pathshala and GS Terminal. Electrical Junction contains short videos of great concepts. Pathshala provides you animated content. JE preparation can be done through these 2 channels, Unacademy SSC JE and GS Terminal. And you can refer the other channels to the other friends in respective branches, so that they can also be benefited. At last, I would like to say, please share, like and subscribe to this channel. Subscribe to this channel, and not only subscribe, press the bell icon, so that you get notified whenever a new video comes, and share these videos among all your college group, among all your friends, so that we can create the first ever revolution of free education in field of GATE and ESE. Thank you to everybody for dedicating time to watching this video. Please move on to the next one as well and take the benefit of all the free content that we are providing. And in case you have completed the series, do make sure you watch the other subjects available on this channel. Thank you.